Hello pre-calculus students, and welcome to a video that is a review of what a function is, some of the language of a function and what it actually is. So our objective here is to apply the function terminology and be able to determine whether or not, when we're looking at an equation of a relation, to determine whether or not it's a function. Okay, so let's first define relation and function. So we've got our two definitions right here. Both of them have to do with sets and a connection between elements from one set to the other. Both of them order matters, so something in the first set, which we call the domain, will lead to something in the second set by whatever mechanism the function has to offer. So if the function is the identity function, then it just doesn't change it. An element in the first set will be the same as an element in the second set. Well, if it's a squaring function, it would change. It would become the square. Okay, and everything in the range of the square function would have to be positive because it's being squared. Okay, so what makes a function distinct from other relations is that each element in the domain corresponds with exactly one element in the range. Okay, so each element in the domain determines a single output. That's another way of saying it. And this is important because if you take a machine and you put something in the machine and you know what's going to come out, that's what makes it a function. If you don't know what's going to come out, then it's not a function. If there's more than one possible output for a given input, it's you don't know what you're going to get. Okay, so that's kind of the idea there. All right, a little bit of the language of domain and range. The domain is the set of first coordinates in the ordered pair, and the range is the set of second coordinates in the ordered pair. In each ordered pair. Okay, so let's say, let's keep consistent here, in an ordered pair. Okay, the domain is the set of inputs, while the range is the set of outputs. The domain of a function is the set of pre-image points. So the set of pre-image values, I should say. So pre-image, and then in the range you get the set of image values. While the range is the set of dependent variables. They depend on the inputs. They're outputs that depend on whatever the function does to the inputs. The inputs are called independent variables. Okay, if x is the input, then f of x is the output. You probably were going to guess y there, but we're going to stick with f of x. Sometimes we consider x to be where something is. So x is where. When I say where, I mean on the x-axis, or from the x-axis, and y is what it is, or what's the height. Okay? So y, or the f of x, that's the height. So I could say, where is the function got a height of 3? I'd say where. And I would say, what is the height at when x is 3? So something like that. Okay, the meaning of f of x, just to make sure that you are up to speed on this notation, we read this as, it reads as f of x. Okay, it's not f times x. And f is the name of the function. So if this were g of x, g would be the name of the function. So f is the name of the function. And here's a little bit of that where and what thing. We can say that f of x is the value at x. Kind of has that feeling already of what is the value, right? What is the value? And at kind of has that sense of where. Where are we looking to find out what the value is? All right, so with functions and with many things, implicit versus explicit. Explicit is when it's laid out already in terms of a function. So you might have something like y equals negative 3x plus 5. When it's solved for y, that's explicit form. Or you could also have f of x equals negative 3x plus 5. Now that same function could be written, now if this is slope-intercept form of a line, we could write 3x plus y equals 5. They're the same equation, but because it's not solved for y, we call that implicit. Okay, a couple more examples. Okay, so I just wrote down a couple more examples so you could see the difference between implicit over on the left and explicit over on the right, always solved for y, which we can of course write as f of x. Okay, so let's look at some of the goal here, which is to determine if a relation is a function. So we're looking at a relation, and remember, if this is a machine, and this is these two machines in A and B, these two functions, they're very limited because there's only a finite, in this case only four ordered pairs in the relation. Remember, the x's are the inputs, the y's are the outputs. So if this whole thing is a machine and I say, okay, let's say I throw a 2, what's going to come out? Well, if I throw a 2 in, I could either get here or here. So I could either get a 3 out or a negative 1. And by the very essence of what a function is, that is not a function, because if you have an input in a function, you're going to know the output. If the input is defined, you're going to know the output. Okay? If it's not defined, of course, it's not part of the domain. So this is not a function because the number 1, the input of 1, has 2 different outputs. Oops. Okay, let's look at this one. Now, we don't even need to read what it says or look at the numbers. We just need to focus on the arrows. Of course, it's about different kinds of fast food burgers and the amount of fat in them, but that's not what's important here. What's important is that whatever you have in your input, these are your inputs, because this is where the arrows are coming from, right? These are the outputs. This is where the arrows are going to. For each input, there's only a single output. It doesn't matter, this 23, it doesn't matter that it appears more than once, because if you have a Burger King chicken sandwich, it's going to have 23 grams of fat. There's not another option. So each input only has one output that goes with it. So this is a function. And if you want to write it down, it's because each input corresponds with exactly one output. Each input corresponds with exactly one output. All right, so let's look at these from the equation point of view because these are way more common equations in this class than stuff like this. Okay, this is just sort of to get you the main idea of what a function is. All right, but not all equations are functions. Okay, that's important to keep that in mind. To determine whether or not an equation represents a function, you need to know that no inputs of the equation can generate more than one output, just like every function. So most commonly look for the following 3 things. There's 3 things that can kind of give it away that you're looking at something that's not a function. Okay, so one of them is if you see a y squared term. If there's a y squared term, it's not a function. Because going back to the implicit explicit, if you had a y squared in here and you solved it for y, you would have to have a plus and minus, right? If you had something like, let's say y squared plus x squared equals 1, and you want to solve that, you're going to subtract x squared, and then you're going to take the square root, and something that a lot of students forget is that plus or minus 1 minus x squared. That's what you're going to get. So that means basically you've got 2 different possibilities. If you plug in an x, you could get the positive or the negative. there's two different outputs. If you choose the positive, you're going to get a positive number. If you choose the negative, you're going to get a negative number each time. So that is the second thing to look out for. So a plus or minus in front of either any x or y. So a plus or minus in front of any x or y. And then the third thing to look out for is vertical lines. Just very simple. If you have a vertical line like x equals 3, for example, not going to be a function. It's a vertical line. How could it pass the vertical line test? So, or any vertical line. Any vertical line, of course, is not a function. Okay, so let's just look at 6 examples here and see which ones are functions or which ones are not. And the first one, we have a y squared term. That means it's not a function. So this is not a function. Why don't I have you pause it and see if you can get the rest of them right, and then in a second they will appear with the right answer. Okay, so there's your answers, and the 4 of these that are not functions. I circled the reason that they're not functions. Remember, there's really only 3 things that you're looking out for here, and that's it. Okay, I hope you found this video helpful.